So these graph pattern search problems were in the news in June 2013 pretty heavily, associated with this PRISM system being developed by the NSA. And so an article in Business Week described the kinds of tasks that they're interested in doing. And by the way, the technologies that they're using in this are things you've heard about, or as far as we understand. So the system Accumulo I mentioned in the NoSQL lectures was actually developed by the NSA and then released open source and been commercialized after that. And that's kind of the underlying platform. And then the kinds of applications they want to do using this Accumulo system and other systems are of the type that we've been describing in terms of pattern search. And so let me give you an example of that. So in this Business Week article, they talk about, in October, a foreign national named so-and-so purchased a one-way plane ticket from Cairo to Miami where he rented a condo. Then over the previous few weeks, he had made a number of large withdrawals from a Russian bank account and placed repeated calls to a few people in Syria. And more recently, he rented a truck, drove to Orlando, and visited Walt Disney World by himself. And the point they wanted to make in the article is that individually, none of these activities would raise any flags, but collectively they might. They might be worthy of closer inspection. And whether you agree with this or not, I mean, maybe you'd say that this does not warrant further inspection, but just trying to state the facts of what of what they're doing with the system without putting any judgment on whether it's the right or wrong thing to do. So you can encode this. You can encode these facts in this language, say Datalog, although you could also do it in as a graph, as an RDF graph, and in fact that's actually a little closer to what they're actually doing. But you start off with a database of flights that the government has access to, so you know that they bought a flight from Cairo to Miami, and the last name was this, and that it was one way, and that it was on this date. And you also know that they made some withdrawals. There's multiple records here for various amounts from some bank in Russia on various dates. And what I didn't include here was the calls to people in Syria, although I probably should have, because that's perhaps the biggest flag. But you could write that down too. You could say call from this person to some other person where location of the other person is Syria. So these are a representation of all the facts that they have access to. And the point I want to make is that the aggregation of these facts into a alert of some kind, into a this is worthy of further inspection, can be expressed as a query in these various languages. And in particular, I'm going to talk about Datalog here. So maybe you might flag a person, and this number 1 is just a token to say that this is one flag, and this is a date associated with the time that was flagged in case you want to do further analysis. This might become clear in a moment. You raise this flag if a person bought a flight from some origin to a destination where the origin was one of the flagged airports, I'm making this up, and the destination was a U.S. airport, and the ticket type was one way. Obviously this alone is not necessarily suspicious, but it's perhaps a first step, is that from a airport that we sometimes monitor more closely to a U.S. destination, and it was one way. Okay. Then you might build a table of you might express a query producing foreign withdrawals that are the sum total amount withdrawn from a foreign bank where individual amounts were greater than 1,000, because maybe you're trying to cut out small withdrawals. Okay, and so this says, assuming we're building off this withdrawal table, we add up the total for each person coming from a foreign bank. Okay, this could maybe be called big foreign withdrawals instead of just foreign withdrawals. Okay. And then the flags are perhaps associated, well, when the total amount across all these withdrawals are greater than some fixed threshold, here I've said 10,000, maybe that represents a flag. And notice that these flags are the same relation as these flags. In Datalog, it's okay to have multiple rules like that. And the semantics of them is you're going to union all these results together. So you can imagine expressing this in SQL as well, where I query for a bunch of records and query for another bunch of records and then union the results together. That's what's going on here. All right. And then we skip the conditions on the calls to Syria, although again those would be easy to do and probably good examples to include. But maybe we have this database of all the vehicle rentals with attributes, the person who rented it, the vehicle, the origin, the destination, and some kind of a date. And so we write a query producing yet another flag when someone rented a vehicle where the destination was some important location. And this one's probably not the greatest example of something that would generate a flag, but it's something you could look for, and you can imagine making this a little bit more complicated. Okay. And so all these flags together, you can write another query in Datalog. And again, I haven't told you too much about the details of Datalog, but one thing you'll notice here is that I'm using aggregations in the head of the rule, just like you can in SQL. So select person, sum flag, min date, max date, group by person is the same semantics as what I'm showing you here. So if we add up all the total flags, now we have a relation with people, their total flags, and the date range for which those flags occurred. This won't get you exactly the right results because we didn't really filter much on dates, but you can see the argument I want to make is that it's not too much code, it's not too much work to try to express these English questions you have over this massive graph in terms of a logical language like this. Okay, and so maybe finally the alerts, things that warrant more human attention by some analysts, are things where the max date minus min, within the span of just 10 days, the total flag count is greater than, say, 3. And again, one problem I've sort of pointed out with this is giving you the total across the entire range of time for that person. And so you may want to bucket this by weeks or months, and I haven't expressed that here. Okay, so what I'm hoping to do is whet your appetite that these kind of rule-based logical languages can work with a big graph, can work with a lot of relations, and can express fairly complicated conditions. And they're in some sense, they're all you need. If you have a way of implementing this at scale efficiently, this is kind of all you need to do fairly advanced analytics. Okay. So let me give you one more example of a Datalog query. So we want to know who contacted who and when they contacted them, but we don't really care how they did. And this is a simplification of something we saw in the previous example. So we say person 1 contacted person 2 at some time if person 1 sent an email to person 2 at some time. We also say person 1 contacted person 2 at some time if person 1 called person 2 at some time. And then finally we say person 1 contacted person 2 if they sent a text message at some time. And so the point here is these would most likely come from 3 very different sources, right? As the government is doing whatever they're doing to get email, again, whether you agree with this or not, that's one company or one source. Another source is who called who, and a third source is who sent a text message to who. And so combining all these together doesn't necessarily take a lot of work. You can express these in these high-level languages, and this is, I would argue, the right way to approach these problems as opposed to a lot of low-level code. Okay. So let me give you one more example. Who could have known before June 3rd that some event was going to happen? Maybe you know for a fact that someone named Sam knew. Okay, so you're starting from that point. Well, who else could have known? Well, using this same trick we used in the to build up a contacted relation, you can do this again. Well, we know person 2 knew if person 1 knew and person 1 emailed person 2 before June 3rd. Sorry, that's the other condition we're looking for, right? And we can also argue that person 2 knew, potentially knew, if person 1 knew and person 2 met with person 1 before June 3rd. And so the point I want to make here is that we've referenced the relation that we're creating, new, we've referenced it in the body of this rule as well. So there's a recursive relationship now, right? It starts with Sam, and then basically we find all the people that Sam emailed before June 3rd, and they're in the final result. And then all the people that those people emailed before June 3rd, and they're in the final result, and so on. And you can do this with met, and you can do this with called, and so on. So this recursive relationship, this self-reference, is the difference between Datalog and SQL. You actually can express this kind of thing in SQL. There's Microsoft calls them common table expressions, and you can use the with clause to do this recursive stuff, but you'll find if you try to do this in practice that the implementation of those features is a little bit poor in many of the commercial databases, and there's various limitations. For example, you can only have a depth of 100 recursive steps, which is sort of arbitrary and much too small for many of these applications. You also find that the performance of these varies wildly and is not particularly good. So it's not clear that the customers of relational databases have been demanding these features. But I'd argue that increasingly this is what people are interested in. And my evidence is examples like we just saw from the news. The fact that graph-specific database systems are emerging, Neo4j is getting very, very popular. There's various systems for processing graphs on top of MapReduce, and we'll talk about a couple of those, and so on. RDF systems, these so-called triple stores. So the fact that graphs are becoming more and more important suggests that this ability to traverse the graph recursively is becoming more and more important, which motivates perhaps a move from SQL relational algebra languages to this Datalog relational algebra language. And so my prediction is that you're going to see Datalog pop up more and more often in industry. Okay.